In this lesson, I'll show you how to find the reference angle for angles less than 360 degrees and 2 pi. This is part 2. I've decided to make this video because in part 1 we did not have any examples that were in radians. This video contains 4 examples, 2 of which are in radians. The question reads, find the reference angle theta prime for each of the following angles. Starting with A, we have theta is equal to 210 degrees. Now take a look, 210 degrees is positive, so it'll be going counterclockwise, and it will be right here. This terminal side represents 210 degrees. If we want to find the reference angle for a terminal side that's in the third quadrant, we take our angle, which is 210, and subtract from 180. Remember, the reference angle is always relative to the x-axis, not the y-axis. So we either add or subtract by 180 depending on where our terminal side is. In our case here, we subtract. Subtracting these two, we end up with 30 degrees. In question B, our angle theta is 7 pi over 4. Once again, 7 pi over 4 is positive, so we'll be going counterclockwise. Now 7 pi over 4 is 1/4 less than 2 pi. If this 7 were an 8, you would have 8 pi over 4, which is equal to 2 pi. This means that our angle has to be in this quadrant. It's 1/4 less than 2 pi. And if we were to divide this into quarters, you would find out that it would be somewhere here. Now to find the reference angle for this particular angle, what you do is you take a full circle, which is 2 pi, and subtract it from your angle. So if you're over here, you'll subtract 2 pi from your angle. To do this without a calculator, we need to find a common denominator. In our case, it's 4. Then we cross multiply. 4 times 2 pi is 8 pi. And 1 times negative 7 pi is negative 7 pi. Therefore, our answer is pi over 4. This is our reference angle. Notice that our reference angles so far for A and B are acute angles that are positive. They're always less than 90 degrees and they're positive. You want to keep track of that. Our next example is pi is equal to negative 240 degrees. Some people might have a hard time visualizing where this might be. The negative suggests that we're going clockwise, and negative 240 is beyond 180 in magnitude. So if we're going this way, it would be somewhere in this quadrant, the second quadrant. If you have a hard time visualizing that, just find its coterminal angle. Add 360 degrees to this. If we add 360 degrees to this number, we end up with 120, and now we know that our terminal side has to be here. That being said, to find the reference angle in the second quadrant, we take 180 and subtract it from 120. This gives us 60 degrees. Lastly, in question D, we have theta is equal to 3.6. Given that they didn't give us a unit such as this degree symbol, we assume that's in radians. 3.6, well, remember, a full circle is 2 times pi, which is equivalent to 6.28. A half circle is 3.14159, and we all know that that's pi. 3.6 means that it's just a little bit more than 3.14, therefore we can assume that it's in this third quadrant. If an angle is in the third quadrant, and given that this is in radians, we take 3.6 and subtract it from pi. You'll need to use your calculator for this. 3.6 minus pi gives us approximately 0.458. Those are the answers to the questions, and that is how to find the reference angle for angles less than 360 degrees or 2 pi radians.